So my name is Nai Ding. I work as the senior scientist in the neurotechnology studio from the program for interdisciplinary neurosciences in Brigham and Women's Hospital in Boston. And for this seminar, I will mostly serve as kind of a live demo for the beginners of the NIH, the Fiji ImageJ users. That's to talk some very basic concepts about the digital imaging analysis and how the ImageJ can help you on some of the routine imaging processing project. Getting ImageJ is actually quite powerful, and once you get to know more of it, more experience, you can use it to solve some very complicated problem. But for today, we'll just only cover some basic topics. And also depends on the feedback, we're probably going to host more seminars on the ImageJ. So if you want any specific topics you think that should be covered, you can just let us know. We'll try to see if we can keep this as kind of a series of the seminars working on the digital image analysis with ImageJ. Okay. So for people who actually have downloaded the material, when you open the material, you will be able to save those kind of the folders with the image. And we also have a simple function. Here is basically, I listed several of the how to download the ImageJ and some kind of what I consider as the most basic, you will commonly use the functions. You can use this as a reference. So if you look at the page number 6, so basically once you open the ImageJ, like for here, when you open ImageJ, the first thing you're going to say is that quite different from some very common commercial imaging software. When they open it, they try to occupy your whole screen. Getting? They want to have a bigger screen and they want to occupy the whole screen. When you open the ImageJ, the Fiji ImageJ, the symbol will be on my desktop here once I open it. It's actually only open a very small window. That's the way just it is. It doesn't mean it's a simple program. And if you look through those the image menu, like I go to my image, I click on this one, you can see a list of selections. And I say I'm going to have a stacks. If I have a stack image, I want to do some operation on this image, I go to the tools, and something like this, like a reverse. You'll say, if I have a stack image in a Z stacks, and I just want to reverse it. Getting? So this is the function you are going to find. How do you know where to find it? That's kind of, you just need to play around it to get experience with it. So in the handout, when I show in the red texts, it show you how to find this function. So if I, in here I said, in the red text image, arrow to stacks, tools, reverse, you will know how to find this question. It's in the top menu, it's the image. Then I go to the stacks tools. Really. So for example, if I do some like a color image, I want to do get the color image, then split all the channels. You will see this is the image, color, split channels. That will be the image, color, split channels. Okay. On the NIH ImageJ website, you can, this is NIH ImageJ website, you can actually in the documentation, you can find this user guide. This user guide is not up to date, but actually can serve as a very nice reference when you want to go through all the manual trays to find the functions, the operations you need to do on your image. Okay? So first thing we'll see ImageJ as the image analysis software. One of the best features, I think the advantage of this ImageJ over those commercial software One will be it's free. You can download to any kind of platform on your office computer, on your home computer. The other is actually works very nice to open different images under the different format. So if you open, I will say open image by a format. Once I get into here, here I have a selection of the images. Once you say through the type here, you will say there's a different file type. As we are doing any kind of the image through the scientific equipment, every single company has their own proprietary format on the file. So they have all different kind of formats. Okay? So it's important to know that your analysis program can open these images. So for the ImageJ, make this very simple. You can use the file, this one. File, you can open it. You can also use a file import to import a different format of the image. But mostly you don't do it in this way. You can just drag the file into the ImageJ main menu. Let's say if I want to do, yes, the most simple one, the TIFF one. I'm on a PC, so I just use the mouse, the left click, drag it into here. Then it will open. Okay. And once it's open, you can use the magnifier in the ImageJ. That's main menu here. Left click, you will be zoom in. You will begin to see those individual pixels. On the PC, the right click is zoom out. And you can also zoom in, and then you click on the hand sign here. You can just move around. And when your cursor, the mouse cursor is moving around on the image, you can take a look on the main window about this portion. You begin to see now it will show that x equals to 275, y equals to 235. That's the xy coordinate in the image. And the value, that means the pixel intensity. In here, we have RGB color, so it actually gives you 3 numbers. That's the intensity value in the green, red, green, and the blue channel. Now let's see if I can uncheck it. So this is a color image. I can use the image, color. I can split the channels. So now it gives you 3 channels. So that's where in the blue channel, this is where the green channel is, this is the red channel is. Sometimes you'll see it doesn't showing up in the green, blue, or red color. That doesn't mean it doesn't matter, because those color, we normally call it the pseudo color. It doesn't really give you real information. The real information is contained on the pixel intensity inside each pixel. Okay? So here we use this red because we know that when we take the picture, we probably use the red channel filter to collecting the data. So we know the color is mostly in the red range. Okay? So if you want to assign it to the color, you can use the image lookup table. Then you can choose which color to assign. Okay? So all this, the function you can find in the simple function file I include in the material. So this is, I think this is red channel. I will assign to the red. Then I click this one. This is green channel. Lookup table green. And then you can save them individually. Okay? So this is only a simple TIFF file, but many times we're getting on the company proprietary file, like for this one, the AX5.zvi. So this is a file format.zvi by the Zeiss microscope. To open this file for the ImageJ, in most cases, you just drag it into the main window. To open, sometimes they call the bioformat import. Bioformat imports the options. When you get experience, you can check on the options how you want to open the image. but I normally just uncheck everything. I want to open the image as raw as it is. I just click OK. So it will open. You'll probably say it's kind of a black image, but this just means that intensity level is low. It doesn't show up. So in our case, we can do a very quick brightness and contrast check on this image. Go to the image, adjust brightness and contrast. At the beginning, if you just purely new to the ImageJ, you may feel there's a lot of the functions that you need to remember. Unfortunately, there's no easy way to go through that. You want to get experience on any software, just need to practice on that. And everything I showed here and listed in the simple function file will be what I consider the most commonly used one. So if you plan to later on to use the ImageJ on your imaging analysis software, you're going to use it all the time, okay? You will remember it. So this is image, adjust, brightness, contrast. Normally you just click auto, okay? It will give you the image. So this is a cell wound assay image. So those are just the cells. The user use a tip to scratch it. So there's no cell. We create a wound line in here. And then we'll see that how this cell grow up through the time. So we're going to try some other files. So here's the FITS. I actually don't know what that file is. Something about the astronomy from the telescope thing. I just download some sample image. I didn't do anything on my Fiji. I just move it in. It opens it. There's a 4 images in it. I'll try to show some more contrast on this one. I'm not sure what it is, but you can actually open it quite clearly, and you can get all the, if you look at in here, when I move the mouse into the image, you will see at each X, Y, and Z, which is the slices number, what is the intensity value at that pixel. So basically, all the digital images is a multi-dimensional matrix. You have your X, Y, sometimes including the Z, the pixel index, and then you have the pixel intensity value. Once you have all this, you get all the information from the digital image. For the imaging core I worked, we also work with various the confocal and the fluorescence microscope. So if people do this before, you will know the lib file .lif file is actually the Leica from the Leica microscope. They call the Leica image file. So this file is the same thing. You just drag it into it. Once they open the biforts, import the option, you just click OK. And actually the lib file, it doesn't contain a single image. It contains a series of images. So the ImageJ will open it to tell you you actually have 5, in this case, 5 images in it. Like which one you want to open. I would say I want to open series 5. I open it. So this is, we have 3 channel image. They're all showing as green, but as I mentioned, it doesn't matter. Only you need to know when you take the picture, which channel is which color. You can assign that color later. And once you have this image open, you can always save it as a TIFF file. So everything with the company proprietary image goes, you can open it. And then once you open it, you can save it as the TIFF. Once you save as TIFF, it's kind of now a universal image format. You can open it in any other image software. So that's the same thing for the Zeiss LSM file. And you can also open the AVI file. The video file is a little bit complicated. Sometimes it doesn't work, sometimes it works. It depends on, like, I think it most depends on what the Java version on your computer. I'm not really a computer guy, so sometimes you can just try to dig more on how to open the video file. Sometimes like this, the DCM file, you drag it into it, it may show a error message. Under your computer, you may open it correctly. I mean, here I will see there's some kind of the problem. I will click OK. So I will use another way to open it. Basically, it's the same. I'm going to the plugin, and it's a bio format. I will use this bio format importer. So this bio format thing is the why the ImageJ can open so many scientific image format. Really? It's actually, I think it's actively maintained by some groups in University of Wisconsin. Really? There's a lot of file type it can open. If you download directly imaging from the NIH, you probably don't have this plugin already installed. You need to install them additionally. So I normally suggest people just directly download from the Fiji ImageJ. There's kind of a battery included. Getting they already have many useful plugins included in it. So I will use the bio format importer, and then I'm going to find where the image is. Open image by format. This is the DCM file. I open it. So now I will say there's some kind of the medical image file. Ready? Probably a time series or Z series. Getting. So once you open this one, you can save it, choose it as a TIFF file. We will always suggest you to save it as a TIFF file. Okay, so I will do it here. Save as TIFF. So I'll just name it TIFF here. Save into the same folder. So you begin to say there's a TIFF file here. So once you save it as a TIFF, then you can open this image in any software. Get it? So many times that you can just use the ImageJ as a very quick way to convert some very special image format into a TIFF universal format. So you can keep as a copy, and you can always try to analyze it under any other imaging software you prefer to. So here is actually just in the open microscopy, the orgs, they have a kind of the bio formats, like how many format it's supplied. You can see it's actually quite long list, getting? And sometimes if you have any problem, you can actually contact the group that send them sample data. They may work it out quite soon. That's several years ago. I happen to have one data set I can't open. I contacted the ImageJ team, the bioformat team. Actually, quite a few days later, they just sent me an email said I can just update my ImageJ and it can open it. It works quite good. But normally, currently, it can open. Any image file my users bring to me, I can open it in the Fiji without any problem. So actually, this is one of the big advantages for the ImageJ compared with other commercial software like the MATLAB or any like the Velocity or the 3D imaging. That's many of them, they cannot, they can only open some very commonly used microscope company files, getting, but the ImageJ, you can just very freely to open them. So once you have the Fiji ImageJ installed, the first thing is just to make sure you can open that. The most, I would say the most cool way to directly open it to use the plugin bioformat, use the bioformat importer to open that. And once you open it, and then you can directly save it. You can also do some analysis, the processing on your image, and then save the file. Whenever you do that, I will suggest you to always use the file, save as, save it as TIFF. Do not save it as the JPEG. I would say normally never ever save it as the JPEG. The reason is that once you save it into the JPEG, it will change your pixel intensity. So it actually modified your image. If you save as TIFF, it won't. It will keep all the pixel intensity intact. So if you think about how many time, money, and energy you spend to get the image, and when you begin to analyze it, you just save into the wrong type. Then they change the intensity information. That's basically all the information you have in a digital image. Then everything is kind of changed. To show you clearly on this, we're going to have an example to show you how when you save into the different format, like a TIFF or the JPEG, how much it can change the pixel intensity level. So I'm going to go up and I'm going to go to the Save Image folder. So I will have a macro image here, in the macro file here. It's a kind of ImageJ programming file. You don't need to know how it works. Like many file type in the image, how you open it, you just drag this file, the .igm file, I'll drag it into the ImageJ main window. It will open. I'm going to change this one, the option a little bit bigger. So basically what this macro code does, it will create an image, which is 15 pixel times 15 pixels big. Everything black. All the pixel values, 225 pixels. All the intensity value is 0. And I will only set 4 individual pixels as the intensity value. Everything else is still black. So I'm just run it. You can also just click the run. So it will give you a create image, which is 15 times 15 pixels. So if I move the cursor around here, you can check the pixel intensity in the ImageJ main window in this region. You move around, you will see in majority of the pixels, the value, this pixel intensity is 0. It's only when we add the pixel X at 6, Y at 6, the intensity is 50, is because we set it here. We set the pixel value at X equals to 6, Y equals 6 as a 50. So we only have 4 pixels as 50, 100, 150, 200. So we know for this image exactly value for every single pixel. So now I'm going to save it. I'm going to save into TIFF, and also I'm going to save into JPEG. Then we will say, when we open the TIFF and the JPEG again, what intensity value it shows. So I'm going to have this one. So the first one, I will have this. I will save it as a TIFF. I'll save as a TIFF file. I'm going to overwrite this one. It's a TIFF. So I'm going to do the same thing again. I'm just to have this one. I run it again. This is one, but only here, I will save it as a JPEG. I will overwrite the JPG file here. So now I close this one. I also close this macro file. So now I have 2 pictures. The TIFF, which is a TIFF file, the JPG, which is a JPEG file. So I'm going to open the TIFF file, just to drag it to the window. And then we use the magnifier to. So now if I move into here, again, you can check the intensity value at the main window, this region. So you will see all the pixels outside that 4 pixels, the intensity is 0. And once I move into those, you have the 50, 100, 150, 200. Everything else is 0. That's exactly how we create it. So that's when you save as TIFF, you keep all the pixel intensity intact. That's how we want to save our pictures. We want to save the picture exactly as we created. But now let's say if I open the JPEG file. I open it, and I will just magnify it, put it into the same size. If your computer is good enough, you can actually now you can already begin to see something strange. So I'm going to move around here. You begin to see that the value, you check on here, the XY position and the value, you will see now at X at 12, Y equals to 1, actually begin to have a value 6. Should be 0. Begin to move around. You can also quite some pixels, should be 0, but the value shows up as and then we move to the 4 pixels, which we assign the intensity, like this one. At 6, 6, the pixel intensity should be 50, like in the TIFF one here. You'll see the value should be 50, but now it's only 30. This one should be 100, but now it's 86. This one should be 150, but now it's saved as 153. This one should be 200, now it's 203. And there's quite some the other pixels showing up the intensity. I can use the brightness and the contrast to check how many pixels actually shows the wrong value. I use the image, adjust brightness and the contrast, and I just use the auto. And you will see that actually quite some pixels began to showing up intensity values. Ready? To show it more clearly, I can see as I select this JPEG file, I can actually save it as a text image. For some smaller images, you can save it as a text image. I will name it this JPEG text. And this is JPEG. If I open it, this actually shows the X and the Y. You will see that there are quite some pixels. They should be all 0. Only those 4 pixels shows up as 50, 100, 150, and 200. But now you can see quite some the pixels showing up as intensity. That's not what we want. When we want, if we use this JPEG to analyze the image, then the pixel value is wrong. You will get it wrong. Okay? As you can see, sometimes the pixel from 50 change to 30. That's a very huge change. Here is a very extreme case, but you can just get a feeling when you save it as a JPEG, it changes the pixel intensity. That's not the way we want to save it. As long as you want to still use the saved image for the imaging analysis purpose, you should always save it as TIFF. Sometimes people only want to use the image, save as to showing up some display on the PowerPoint. You can save as the JPEG, that's fine. You can add the legend. You can put more kind of markers on the image to see as you save as a JPEG is fine. But if you still want to analyze the image, you need to save it as the TIFF. Do not save it as the JPEG. It will change the pixel intensity. Like for instance, like here in the TIFF, if I save this TIFF file as the text image, I will save as a TIFF text. So this is our TIFF text file. If I open this, you will say everything else is just 0. We have 4 pixels, 5, 100, 150, 200. That's exactly what we did. So again, the ImageJ, open the pictures, it can take care of it basically by itself once you have this bioformat plugin. But once you begin to do something, some operation, you want to save the images, just to make sure when you save those images, you save it as a TIFF. It's kind of a universal file format. You can open it in any software, and more importantly, when you save the image, you didn't change the image. It's good for you for the future management on that. So this is the first one. It's like for any imaging analysis software, we want to make sure it can open our image, it can save the image. I'm going to quit the screen share. I'm going to try to answer maybe a few questions if you have any. Let me check on some of the questions. Someone asked if many times the TIFF image appear just black when adding to a document. I think that's most likely just the brightness and contrast thing. You can use the image adjust to adjust the brightness and the contrast. It will be showing up clearly. Because it's maybe a 16-bit image, even though your intensity is 2000, it's still kind of black compared to the maximum intensity of like 65,000 images. What is the difference between 8-bit? So the 8-bit and 12-bit is just what's how depth that the intensity can be stored in single pixel. So the 8-bit, the intensity value can only between 0 to 55. That's a 2 to the 8th minus 1. And 12-bit, you can store intensity from 0 to 2 to the 12th minus 1. That's 4095. So actually you have, in a sense, you have a better resolution in the counting, but your file size will be bigger. And to add the scale bars, okay, so I can go very quickly to add the scale bars. Let me go to share. So let's say if I have an image, let's open this one. This is an LSM file. It's a Zeiss, the confocal file. So you want to add a scale bar, you just go to Analyze, Tools, Scale bar. Okay. Go to Analyze, Tools, Scale bar. So you can choose, you want to add it as 50 micron. This was showing as a 50 micron. You can change the font size, make it bigger. You can also say, I want to put into the upper right. The ImageJ scale bar is not a very fancy one. It only adds your various, just a simple one. Sometimes you may want to go to other software. You want to make it look better. But if you just want to show how the scale bar is, you add it. And then you, let's say I go to the lower right. You click it, okay, not added. But just keep in mind, once you add the scale bar, you actually printed this one on your image. Now your pixel intensity, you will check on here. Began to high. Okay? Before it should be very low around here, like a 40. But once you add it here, the intensity goes. Actually, this one. I think that something may change it here. But the idea is that once you add a scale bar, you actually print it on the image. This is not your raw image anymore. So once you analyze, you want to analyze the image, you should go back to the raw image without the scale bar added. Okay. We're just going to go to the second part. So just to sum like the measurements and the segmentation, we'll go to the identify cells, the menu. So the digital imaging analysis is a very big topic. So for today, we just want to cover the simple one. We use a simple topic. That's like, I want to count the cell. I have an image. I have many cells, sometimes a few, sometimes many. I want to identify those cells. I want to do the measurement. I want to count how many cells in the image. What are their size? What is the intensity? And some other parameters for each cell. So now I have an image called cells. I just open it. So this is actually kind of a DAPI staining on the image. So our goal is to try to say, I want to know how many cells inside this image. For each cell, what are the size of the cells and what's the total intensity inside each cell. And once I know the size and total intensity, I know what's the mean intensity inside the cell. So for this example, I will do it in a more kind of less kind of smart way. I will say, I just do it manually. And many times you may realize, sometimes you just have to do it manually. No one want to do it manually, but the image is just too difficult to ask the computer to do it automatically. And it's your data, you just have to do it. So that's assuming we only have a few images like this. I just very carefully draw the cell outline, right? I want to how many cells? I just draw this one. So I'm going to first use this one to zoom in like that. So I'm just going to manually draw this selection. So draw the selection, you can use, there's a 4 buttons on the main ImageJ main window. You can draw a rectangle one. You can also draw a circle and oval one. And for the cells, most likely you're going to use this freehand thing. You click on this one, then you draw it. This is not very good. Let's just draw it again. Yeah. You can also use the polygon things. Then you can just click, draw the line, click, get all the vertex of this polygon. So this is what we call the selection. Those yellow thing, get it? We will call it ROI, which stands for the region of interest. And ROI is not some terms just in ImageJ, it's actually in basic concept of the digital imaging analysis. Everything relies on the ROI. It's basically what part in the image you want to analyze. You're interested, you want to do the measurement. So once you have the ROI, here we manually draw it. We want to say, I want to measure the size of this cell. How do I measure this? Make sure you have this selection on. I'm going to measure this. That will be the analyze, measure. Get it? It will measure the current selection on the image, which is the cell we draw it here. So let's say I measure it. It will show me this is the size, the mean intensity, and the total intensity inside the cell. So the size is here is just the integer, so that's actually just the pixel number. If I say I'll zoom in here, you began to see those individual pixels. That means how many pixels inside this cell. And you can control what parameter you want to measure for the region of interest you just draw. So that's in the analyze set measurement. So this is the basic parameter the ImageJ can calculate for you for every single region of interest you selected. You can choose all of them. In here, we don't care about some of the shape things. Maybe I care about the parameter of the cell. So I want the size, the area, the mean intensity. And the integrated density actually means the total intensity. We can get the center of the mass, which tells me basically the position of the cell. So let's say I want this 5 parameters to be measured. I click OK. Then I go to analyze. I measure it. So this will be give me, this is the size for this selection. This is the mean intensity inside this selection. The XY, this is this center, the weight center for this cell, and the parameters, the total intensity inside. Currently, we do not have the pixel scale of this image. We lost it somehow. So the pixel is just, so the size and the area, the unit is just the pixel. We only know that's how many pixels. If you actually have the pixel scale for this image, this will mostly show you as the micron square or the based on the pixel scale you have in the image. So once you have this, you can actually save this result directly in a Excel file. Let's say this is the menu. I will just name it as the result. I will save it. I will close this one. So we have the result in the Excel file. I open it. So that's it. You have the first, there's the index for the cell, the size, the mean intensity, and the average. The weight center parameter, and all the total intensity. So let's say if I want to measure two cells, okay? So this is one cell, I measure it. And I'm going to draw another cell. Then I'm going to measure it again. So this is the second cell, a different size. Then you can begin to draw more cells. Then I just save this file. I'll just save it. Then next I will say, okay, in this one, in this picture, I measured 3 cells, and this is the size, the mean intensity. Okay, you can do some statistic in the Excel. But people will ask, like, where are the cells? People want you to show when you select the cell or you select the neuron, you select any kind of cell compartment structure, some puncture shape thing. Like you selected the right one. Okay? You also want to make sure you did it right. Okay? So we need a way to show how all those selections are. So in this case, we'll say, let's move in again. Let's say I draw one in this cell. I'll draw this one, and actually I want to save this region of interest. So I can show me where is it later. Okay? Maybe I want to do some change on this one. So once you have the yellow selection, get it on, what you can do is you just press the T on your keyboard. It will come up something like that. They call the ROI manager. If you didn't get it, it's fine. I will close this one. I will do this in another way. I'm going to go to the ImageJ main window, analyze, tools, and the ROI manager. As I mentioned, the ROI stands for region of interest, just above the scale bar. Once I click on this one, it will show you the ROI manager. You can click add. It will add this current active selection to the manager. As you can see, there's also like a small t, lower t back here. So if you just press the T button on your keyboard, you can also add it. So now let's say I draw another one. Okay, seems there are some questions there. I will just finish this and I will take some questions from there. I'll just draw it here. Then I'm going to click Add. So now you will see there's two regions. And I'm going to do another one very quickly. And if you want to see what cells are already saved, you can click Show All. This actually show you have already get 3 cells. The index 1, 2, 3 is the order up here you put on. Yeah. So this is the first one. The second one is this cell. Okay? And now let's say you want to measure, I already draw 3 cells. I want to measure all 3 of them. I don't do it here, the measure only do the active one. Actually here, I will use the measure button in the ROI manager window. It will keep us the set result. So 3 cells. The index here means the order of the ROI in here. So once I have this, I can save this file as a result. I will overwrite it. And I can also save this one, which is show how we selected this cell. I will save it in the ROI manager. Then more, save. What you will do is, in the ROI manager, you want to save all those selections. More, save. I will name it this. I will name it here as 3 cells. I will save it. So now I close this. Let's say I already saved it. So now you will see there's the one we just saved. It's a 3 cells. We name it. If you check it on the, this is actually a zip file. You don't need to do anything on this zip file. Okay? Just keep it there. You want to open this file like you open any other file in ImageJ. Yes. You just drag this one into the ImageJ window, the main menu window. It will show up. And then you click Show All. It will show you all this file. So basically what you do is you save this region of interest file. You save the result file. I will say, this is my image. This is 3 cells I measured. Their size, their mean intensity, the total intensity. People ask you, where are those 3 cells? These are the 3 cells. Number 1, 2, 3. Then you may realize actually the number 3 is not good. Somehow it's maybe a dead cell. Should be counted. I select this number 3. I just delete it. Now we only have 2 of them. Now I draw the right one. Maybe we actually should include this one. I add it. So those are the 3 cells we have. And I can draw a new one. Yeah. And then I'm going to save this. This is actually our new selection. I still keep it for the 3 cells. And I'm going to do a measurement. And those are all the 4 cells. I will save it as the same result. I'm sorry, this one is open. I have to close it to save it. So we have the result file. It's an Excel file containing result of 4 cells. And we have the zip file, which containing the selection of these 4 cells. So like for today, you can draw 10 cells in an image. You feel tired, you can just stop it. Too much for today. And then I can come back tomorrow. I open the same zip file. I can keep adding more cells, or we can modify, we can delete something cell that is, which we realize actually wrong. So basically you save those zip files, getting? Then it will show you how you select this image. So eventually you may end up with a file like this one. I have it in the folder. You drag it in. Those are the selections of files, getting? In this case, you can manually draw them. You can actually, if you get more experience with the ImageJ, you can ask the software to do it. Actually, I use the software, go through some steps to ask the software to automatically draw the cells. And then I will say for all this one, I want to measure the size, mean intensity, total intensity, center mass, parameter, then I measure it. So those are the total of 57 cells. The same thing, if you're moving down here, those are the 57 selections. I save this ROI, I save this with the results. That's, I basically finish the analysis for this image. I'm going to quit this one. I'm going to check on some of the questions. Let me see, I'm going to check on the, how did you choose all of this cell? Currently you don't. The one I added is one I already generated the file. We'll do that in the next step, getting? So here for this one, I just want to show you, sometimes even if your sample is very difficult, but you understand what your sample is. You understand what you need to measure. You can always do that in a manual way. You can manually draw the region you want to measure, and you can select what kind of the measurement you want. Then you can do the measurement. The next step, what we want to do is, if the image is simple enough, we can actually ask the program to do the selection automatically for us. It will save a lot of time because sometimes you just cannot afford to do it manually. I have 100 images per condition. I have 5 conditions. Each image has 100 cells. It's just impossible for me to do it manually. We have to find some way to do it automatically. So we'll try to, the next step is we want to do it in the automatic way. But many times you need to realize, depending on your image, sometimes we just cannot find a good way to do it automatically. Then you need to spend more time to understand what your image is, to try to help find some know your image, the part you're interested in, and the part of the background, you can separate them, and it helps you to do that. So this one that I just mentioned is just for you to manually do it. So at least if we have to do it manually, I can do it in this way. I draw one by one, I add it to the ROI manager, then I can save the ROI manager in the zip file. I can later open it later to add more cells. You can change it to delete some of the cells, and we can do the measurement. So some people are most interested how I can do that for all the 50 cells. So we'll do that in the next section. So for this one, let me just close this one. So let's go back. I will go to the image segmentation for this folder. So this is something like a fixed cells. I just open it. It's kind of the blob image. Some people also ask to say that, so ask if you want to do a Western blot, how do you get the band? So it's basically about the same. They're not the cells, but the Western blot, the blot is kind of dark. You can invert the image to make it bright. It's the same as it. We're assuming all the white objects here are cells. And I want to count how many cells are in this image. The same thing, I want to get a number of the cells. I want to get the size of each cell, the mean intensity of each cell. We can do it manually, as I just mentioned. I can draw this one. I press T to add it to the ROI manager. I want to add it here more. So now I have 3. So it may take me 10, 15 minutes to draw it. And if I have to do it, I have to do it. You know? But for this picture, when I look at it, I think it's a very simple image. I think I don't need many background to understand how to draw the cell. For instance, like my daughter is in the 5th grade. I mean, even 5 years ago, when she was in 1st grade, I can tell her, look at this image, draw the white cells. She can do it probably much better than what I draw the cells. Okay? So it doesn't take much knowledge or some kind of intelligence to understand we want the white cells. The background is black. It's no intensity here. If you zoom into here, the cells, the intensity is around like 200, 190. The background here is about 50, say 60. So I would say if I draw a line, I use a 9. I draw one line. I go to the analyze, the plot profile, which will gives you the line profile you just draw. So the high intensity part is where the cell is. The low intensity part is where the background is. So we'll say kind of all the cells is about 100 intensity. And the background is about like a 60 something around here. So I would say is that if I can tell the software, in this case, the ImageJ, which pixel belongs to the cell, which pixel belongs to the background, then it will be easy for the program to pick up what to do. Because the difficult thing is that the program, when you ask the program to actually say, give me where is the cell, they will ask like, how do I know if that's a cell? But if we can actually do the difficult part for it, I would say the high intensity part is a cell, because we know the cell is white, which is a higher intensity. When the intensity level is low, it's more close to the black region, then it cannot be the cell. That's how we do it. So I would say it's maybe we can set some kind of a value, maybe 100. So everything for all the pixels here, we have 256 times 254 pixels. We check on the intensity of each pixel. If that pixel is high intensity is higher than 100, I will consider that pixel belongs to a cell. If it's lower than 100, I will say it's belongs to the background. I will separate this, all the pixels into 2 groups. Once we do that, I think it will be much better, easier for the program to pick up. So I'm just do this, and this is called the thresholding, or we call the segmentation. So basically you divide all the pixels in your image into different groups. Normally it's 2 groups, your object, your region of interest, of the where's the background, which is the part you don't want to. Yeah. So before we do this, I want you to first do one thing in the warm-up, what we said, because sometimes that we just want to make sure the ImageJ will consider the higher pixel intensity as the white object. I only need you to do one thing. You go to, if you have your ImageJ open, go to the process, binary, options. The process binary options, once you click on the options, make sure the black background is set. Okay? Many times when you open the ImageJ, it's not set. So actually, once you segment it, you try to calculate the background, not the white object. I don't know why they do that. It's probably at the beginning, it did a lot on the Western blob images. In the Western blot, actually the dark black band is actually your object. So they actually want to analyze the dark object. But here we want to make sure let's analyze the bright object. But in our case, the bright white object is what we're interested. So I will just make sure the black background checkbox is checked. So I'm going to begin to thresholding this image, which we will separate all the pixels in the image into two groups, our cells and the background. So how do you do the thresholding? That's the image, adjust threshold holding. If you're going to do any image analysis, no matter what, the thresholding is always the centerpiece of all digital imaging analysis. Everything finally relies on if you can do a good thresholding, a good segmentation, which means you can separate the pixels in your image into the parts which I'm interested, the object, the region of interest, what I want to measure, and the background, which I have no interest in this. Go to the thresholding. So once you have this thresholding, I will suggest you choose this one as the red, which will give you all the thresholding pixels showing up red here as showing in my desktop. And also make sure you click the dark background. Okay? We wanted the bright image to be showing up. So now you see, once you have this set to red and this is a dark background, you can create around those two scale bar, slide bars. Okay? So this is a lower thresholding. This one is higher. So now you will see this is 118. The other is 178. So what is showing up in this image is any pixel showing up red here is actually the pixel with the intensity between 118 and 178. That's your choice in this box. So if I move this one to 255, you will see, because the cells are all white, so we want to include all the high intensity pixels. And we want to select the lower intensity one to adjust this. I don't want to make it too high because only a few pixels actually belong to the cell we're showing up red. I don't want to make it too low because then all the background also showing up as red. I want to play around with this, which I think it just barely give us the right selection of this cell. To make this more clear, I'm going to open this one again and we'll show them side by side. So this one. So this is the image we want to analyze. And this is why when I go adjust it, I will assuming all the red part will represent our cell. So this may be just too much red. This is too less red. So I'm going to play with the thresholding to do something. I will say maybe, I will say 120. You can play it around to find the best, the value which you think best fit. Okay? I choose 120. You may choose 110. You may say this one. And I may change my mind. I'll say, okay, now I change my mind. I think 115 is right. So I will stick with 115. I'm going to tell you why I choose this value later. But as you can see, you will understand what value you choose in this thresholding decide everything you're going to measure on your image. This is the most important part, the parameter you're going to choose to apply to your measurement. You use the higher thresholding, your cell size, once you get the red represented cell, the cell size will be smaller. Okay? You may get in less cells. Okay? You get more, you get less the thresh value, you will see the cell size getting bigger. So you need to find one, which is the best represent the original raw image. I will use the 115. Okay? I think this is the best. So once I select it, now I'm going to actually apply this threshold into the image. So what I'll do is make sure you have on this one, the lower sidebar is 255. This one is 115. I'm going to click apply. Once you apply it, now you see something change on the image. If I move the mouse to this image, you check on the intensity value here, you will see the intensity value are either 0 when I move into the black area, or it's 255 when I move into the white area. So this is what we call the binary image or a mask image. What it does is I separate all the pixels into two groups. That's what I mentioned in the beginning of this section. Yes, we have 256 times 254 pixels. I want to separate them into two groups. One group is the background. In this case, where the group with the value as 0 is a black one, it's a dark pixel. The other are the pixels which we think belongs to the cell. Then we will apply the intensity 255 to it. It's the white pixels here. So this is what we call the mask image or binary image. Once we have this, I think it's easier for the cell, for the ImageJ to outline the white object for us. It becomes quite simple. Let's say for this one, I want the outline for this. You just pick up a pixel. If it's white, it's a cell. If it's black, it's a background. If background, we don't do anything. If it's white here, it's a cell. Then we just expand it to its neighboring pixels. If they're also white and also means they're connected, they belong to the same cell. So I just keep expanding until I reach the edge. Once I go out 1 pixel out, they're all black. That means we reach the edge of this cell, this white object. Then we'll ask the ImageJ to give me the outline. The same thing as I draw it manually. So give me the outline of the interface between the white and the black. In this case, I don't need to draw it by hand. I can ask the program to draw it. But you have to have a mask image to ask it to draw it. You cannot use this image to ask it to draw it because it doesn't know for this pixel it belongs to the cell or not. But here it knows. It's only 2 intensity value. Black is a background, white is a cell. Give me the outline of our white object. So I will highlight this one. To draw this, this will be one of the most commonly used ImageJ functions. If you're doing the cell counting, it's absolutely the most commonly used one. I go to the analyze, analyze particles. All right, you're going to use it a lot. Once I have it, let's put it here. So I will first change it in your selection. I will first ask you to do it like change this one to 0 to infinity, the circularity 0 to 1. So basically, I'm going to ask you to collect all the white object in this image, in this mask image. The size is from 0 to infinity. The circularity also 0 to 1. But I will ask you to say, once you found the white object, add that one to your ROI manager. Make sure you click on this one, add to ROI manager. And I click OK. Now, as you can see, it automatically selected 59 selections, all the white ones. It's selected. You can also, once you have the ROI manager, I can highlight this one, the original image. I click show again. So here's how it's selected on the cell. You can zoom in. Not the cell, not the ROI, ROI. it actually did a pretty good job, I will say. Most of the time, I'll say it's better than you manually draw them. And it draws very fast, 59%. So now I apply to the raw image, I can do the measurement. This is all the cells, the size, the mean intensity, the total intensity. I can save the result. I can save the ROI. Getting? So basically, this is how you do that in a more automatic way. But you can only do this when you have a nice mask image. You have a nice mask image represent nicely what the cells are. Once I have this one, I will say, once you have a nice mask image, I'm going to save it. So I don't want to go through all the things to get it again. I'm going to save it. I'm going to save it as TIFF. So this is the segmentation. I will name this one the mask image. So this is the mask image. You can check out. Yours may be different than me because you choose a different thresholding value. Okay? So you decide what will be the best representation of your cell. And once you have the good mask image, you can always use the analyze particles. So before I analyze the whole thing, okay, I'm going to save this one, the ROI file as ROI set A. So if I check on this one, you look at this one, you may find there's something not so good on this. So let's say if I want to measure all the cells inside this image, I want to measure the size of the cell. And I want to compare the size with a different condition. Then when we look at all the cells like here, the cell number 56, number 57, they are not the whole cell. They're only partial of the cell. So this size doesn't represent the size of the cell, which happens in this image under this condition. Because when we measure it, it doesn't know what the cell looks like. It only gives you all the white object in this mask file. So when we actually want to measure the cell, we need to let it know. We want to measure the whole cell, everything, the whole cell is within the field of view, not those half ones. Got it? So actually, this will be simple. I'm sorry on this one. I'm just close it. Before, if you have manually draw 59 ROIs, you don't close it immediately, you save it first. But here, since I already have the mask file, I can do it very quickly. I just go here again, analyze particles. Here, I just click on this one, exclude cells on edge. So any white object is attached to the edge, it doesn't count. Everything else keeps the same. Sorry, now currently this says I just need to do something to unset this. This one, I'm going to analyze cell. I check I want to add everything selected, ROI into the manager. I want to exclude on edges. Okay, it's okay. I think I have selected. Sorry about this. Really. Make sure I didn't select any region. I want to measure on the whole frame. So now, as you can see, apply this one to the original one. So all the cells, as long as it's on the edge, we don't count it. So now when we measure the cell size, we measure the whole cell size. We don't measure the partial cell. Okay? That's something you may think about when we analyze the particle, depending on what you want to, what is your interest region into that. And another thing that you can say is that, let's say if we want to go to this cell, it may not be a cell. It's kind of too small, I will consider it. It's maybe just a debris of the cell. I know the cell should have a reasonable size. When it's too small, it cannot be, we don't count it as a cell. So actually we can also apply this one. So once you have the raw image, I can just close the ROI. I'm just doing this one again. So I will say, I want to add to the manager. I don't want anything on the edge, but then I also want to kind of thresholding on the side. I want everything to at least, I will say 100 pixels. You can also add the upper limit to it. So everything has to be at least 100. Let's see. So now you will see, we don't include this one. We also don't include this one. You may feel actually this one, maybe we should also include it. Yeah. Okay. And we can change it to include the, depending on your selection. I will say maybe this is 85. There's still now we include this one, we still don't include it. So once you have a nice mask image, you can actually use this circularity is actually the shape one. If it's not too round, we can also exclude it. So you can use this one to get based on your knowledge of your cell. Like your cell should be what size, how circular it is getting. You want to count the one on the edge or not. You can get a very quick this. And then I apply this one to the raw image. Then I will do the measurement. As we said, you can save the result as an Excel file. You can also save the ROI file. It will show how the cell selection is. Then you can manually add some cell that should be counted. It's not counted in this way. That's manually wise is much less work to do in here. But also in this one, you make it very kind of consistent because you only thing you set with these images, we set the thresholding value. I'm going to quit the screen sharing and try to answer some questions. So from the Benjamin said, is it possible to measure and determine if a cell is expressing multiple markers? In that case, you need to make the mask file on different channels. And then you want to work on those, the separate mask files, just to say if they have the overlap or not. Okay? That's probably will be a more advanced topic. It's not included in today's. Okay. Could you define a manually ROI on which to count? You can actually do this. I will go to the share screen now. So let's say I close this. I will say, if you can first select one of here. I will say, now once you have this selection, then you do the analyze particles. It only gives you the selection within the original selection you put it down here. So that will be here. Before, when we work on this one, we do not have any active selection, so it will work on the whole frame. But if you actually have an active selection, it will only work on the ones that's now in the bottom here. it will only give you the selections on this. When you have a selection, how do you apply it? You just make the image you want to apply as the top image. Then you can just click the show all. It will apply to it. So now if we put down here, it will only apply to the active image, which is the one on the top. So finally, I will just using this one to do it what we did in the I'll just use this one in a more like a real scenario. Like if this is a cell, the same thing, we want to identify how many cells in here and the size of each cell. So basically the similar thing. I go to the image, I'll do the threshold. I change it around to make sure I get the cell kind of the outline for the cell. Once I think this is good, I click apply. And once we have into the mask file, we can actually do something onto it. I can go through the process. This is a binary. So this is also a binary image. Here I will do a fill the hole because I see some of the cell inside is also black, but also it belongs to the cell. It's only the nuclear the region, the intensity is low. So actually I'm going to say I will fill out the holes that's in the process binary, fill the holes. Then everything inside is become white. And also this is actually 2 cells, I believe. This is also 2 cells, but now when I count it, it only counts as 1 object. So I can also do it in a binary one. I can do what's it called a watershed. It's actually separate for me. Once you have a nice mask image, that means you do a good thresholding way to make the image into the mask. You have more functions to work on your image. And now I can see I want to analyze this. I want to say also, I don't want any of the outside on the edge. I also put some like a cell size. I will try to guess about 3 micron square. And I'm going to click. So I didn't clear this one. I'm going to close this. And then I'm going to run it again. All the side has to be at least 3 micron square. I don't want anything on the edge. This is a selection. So if I go, so this is my cells. Okay. You can check on it. This is the selection. It's actually quite good. But some of them you may say, this is also 2 cells. I should be separated. In this way, we can't really separate it unless maybe we have some like a DAPI channel saying the nuclear. We can use that as a reference to separate this. But generally, we do a thresholding. We get a nice mask image. Then I just use the analyze particles. It can automatically select it for you. Okay. I'm go back to stop the share. This one just to check with some of the questions. Does ImageJ has a good registration techniques? You can search up the plugins. Actually, in the plugins, they have a lot of registration, the algorithm. You can Depending on your sample, you can try them. I didn't use that extensively. Okay, that's it's the use the plugin. There's a registration. So depending on how much you installed on your ImageJ, there are quite some of the rigid searching also like the, I think this one's also sometimes I use, and I mostly use this one and the rigid registration. Those things you just have to test it on your data. You can find specifically go to the internet to find maybe there's some specifically plug-in on the registration will be good for. As I mentioned, the ImageJ is actually very powerful software. So I think in my experience with the users, mostly on the fluorescence images, 95, I think more than 95% the case that ImageJ is enough to handle in the imaging analysis. But as any image process software, as any software, you just need to get familiar, comfortable with it. You need to work with it, and it takes time. I think, as we mentioned, we are going to put the seminar, we'll record it, we'll put it online. We also intend to put some more instruction videos on the ImageJ on our course, the training resource, the website. You can check back later. You can also register into our newsletter, to receive future announcements for the seminars on the ImageJ. Okay, I guess I'm already over the time, so I will just finish it here. And I will try to stay a few, like more 10 minutes, try to answer any questions. You can type it in the chat. And again, thanks for the coming. We'll try to keep it as a more regular offering on the ImageJ for the online, the seminar, and the instruction videos. Okay, thanks.